Here's a nice recap. We have covered the following equations. The first was our point slope, and the second was our slope intercept. So we are now bringing back our standard form of a line. So what we'll do today is define it and then work with various examples of how to put various types of linear equations into standard form. So we'll start with our definition. So we've seen this form already, ax plus by equals c for the standard form of a line. But now we are putting some conditions on the values that a, b, and c can be. So the first is that a has to be a whole number. And if you needed a little refresher, those are the whole numbers. They start with 0 and then just keep going. A has to be a whole number. B and C have to be integers. Another refresher. Those are values that are integers. Those are whole numbers, but they can also be negative as well. So lastly, your A and your B can't be 0 at the same time. So we'll start by just walking through the scenarios when A and B are 0. When we work with horizontal and vertical lines in standard form, they don't change in terms of how, in terms of their appearance. So keep in mind, folks, vertical lines look like that yellow line. For example, that would be the line x equals 3. One thing to keep in mind, the slope of a vertical line is undefined. Horizontal lines look like y equals b. And they look like that yellow line. That example would be y equals 7. And we want to remember for horizontal lines, the slope is 0. So let's do a couple of examples that use horizontal and vertical lines, and then we'll do examples for all of our non-horizontal and vertical equations. Let's look at this first example. We're asked to write the equation of a line, and it's a horizontal line that goes through the point 4, -3. You may recall that horizontal lines always have the form y equals a constant. So what we want to do in this example is see what that y value is, because it means that that y has to be the same for that entire equation. So our graph would actually be the line y equals -3. And if we looked at the point on our coordinate plane, it should make sense that our y value has to be at -3 in order for it to have that point for -3 on it. What if this question asked us for the equation of the vertical line that goes through that point for -3? You'll remember for vertical lines, it always has the form x equals a. So now we're going to look at that ordered pair and focus primarily on that x value. So our equation would read x has to equal 4. And once again, if we looked at the point on our coordinate plane for -3, in order for that vertical line to contain that point, it has to be the vertical line x equals 4. But you'll notice that most of the equations that we work with have slopes other than 0 and undefined. So in this problem, we're just asked to put that equation in standard form. I'm hoping that we identified that right now it's in mx plus b form. That's slope-intercept form. We want to have it so that it's ax plus by equals c. We want x and y on one side, we want our constant on the other, and we want a to be a positive value. So for starters, let's try moving that 4x term over to the other side. So if we subtracted 4x from both sides, we have -4x plus y equals 7. Notice that I was mindful about putting my x term before my y term, because that's how it looks in standard form. X plus the y. So I'm in a good place, except my a has to be a positive number. So the only way I can make -4 a positive number is if I multiply every term in that equation by -1. So let's distribute. So if I distribute that -1 to every term, we would get positive 4x minus y, and -1 times positive 7 leaves us with -7. I have this equation now written in my standard form. How about we are asked to write this equation in standard form? Y equals -2/5 x plus 1. Remember, standard form is ax plus by equals c. So let's start by just moving all of the x and y terms over to one side. And by doing that, we have 2/5 x plus y equals 1. We are almost there, but you remember, a has to be a whole number, meaning it's got to be positive and it can't be a fraction. So I need to get rid of that 5 in the denominator of the 2/5. How can I do that? I can do that by multiplying every term by 5 so that the 5 in the numerator, remember this is the same as 5/1, I'm going to multiply every term in that equation by 5. So we're ready to distribute that 5. When I multiply 5 to 2/5, that 5 cancels with the 5 in the denominator. So that leaves us with 2x. But don't forget, every term needs to be multiplied by 5. When we multiply 5 to y, we get plus 5y. And lastly, when we multiply 5 to 1, it equals 5. And now this equation is in standard form. My a, my b, and my c are all whole numbers. So here's a similar problem to the one that we did. You'll notice some messy fractions. We want to put that in standard form. Ax plus by equals c. So we're going to start just by moving the x and y term to the same side. Now when we subtract the 1/2 x from both sides, we now have this new fraction, or this new equation, -1/2 x plus y equals -3/4. Remember folks, a, b, and c, we want them to be integers, and then I want my a term to be positive as well. So we notice that I have a 2 in the denominator that I need to get rid of, and I also have a 4 in the denominator that I need to get rid of. So now what we're going to do is we're going to multiply that entire equation by the number that will eliminate my 2 and my 4 from the denominator. And that would be 4/1, because 2 goes into 4 and 4 goes into 4. Next, we distribute the 4 to every term in that equation. Now, you notice that the 4 is going to conveniently eliminate all of the denominators from my fraction. However, I'm still going to have that a term be negative. So what can I do instead? Kill 2 birds with 1 stone and multiply by -4. So now, feel free to use Desmos to clean up your fractions. -4 times -1/2 leaves us with positive 2x. -4 times y gives us -4y. And -4 times -3/4, well, the 4 on the top will cancel with the 4 on the bottom, and then I have -1 times -3, and that leaves us with 3. So here is our standard form for that equation. What if we wanted to find the standard form of a line that contains those 2 points, 5, 2, and -2, 1? Well, the first thing we need to do before I think about putting it in ax plus by equals c form is I just need this to be in an equation. So we're reintroducing some other equations. Point slope. We're going to use point slope to come up with the equation of the line that contains those 2 points. And you'll notice I have 2 points I can use. Great. I don't have my slope. My slope isn't given, but we know how to find it. So we're going to use those 2 points to find the slope of that line. So we plug in those points, y2 minus y1 over x2 minus x1. And then we identify that that leaves us with -1 over -7, which simplifies to +1/7. Well, next I have my m, and I can use either of those two ordered pairs. I'm going to use 5, 2, and I'm going to plug it into my point slope. So folks, when we do that, we're left with that. Y minus 2, because that's my y1, equals our slope, 1/7, times x minus 5, my x1. So now we just need to clean this up so that we can get it in that pink equation, ax plus by equals c. So we're going to start by distributing the 1/7. Next, we want to get the x term combined with the y. We want the x, y on one side, we want the constants on the other side. So we subtract 1/7 x. You'll notice though that on that left side, we still have that 2 lingering. Let's put it over to the other side. So folks, here we are right now. We at least have our x and y term on one side, and then we've got our constants on the other side. And we can clean that up, but I would suggest let's get rid of those fractions. I want to clear the fractions, and we do that by multiplying by the value that would eliminate all of our denominators. And it looks like that value would be 7. Remembering, we can write that as 7 over 1 if that helps. And you'll also notice that that a term currently is negative. So let's just multiply everything through by -7. So the mega distributing begins. We have -7 over 1 times -1/7. That just leaves us with 1x. We have -7 times y. That's -7y equals -7 times -5 over 7 gives us +5. And -7 times +2 gives us -14. So the last thing we do here is combine those two like terms, 5 minus 14. And we have our standard form, x minus 7y equals -9. So looking at this last example is similar to the previous one, actually. But we're given a graph, and they're asking us to write that equation in standard form for this given line. So the one thing that we need to do that's a little bit extra is we first need to find out 2 points that we know with certainty are on that line. And that looks like the point 3, 2 and 5, 5. Next, what's convenient is since the graph is given to us, let's just find the slope by taking rise over run. It looks like we rise 3 and we run 2, and it was up and to the right, so that's +3 over 2. Next, I'm going to go back to my trusty point slope equation, and I'm going to use that m and that point. And in point slope form, we have y minus 2 equals 3/2 times x minus 3. So next, we're going to distribute the 3/2 so that we can get this in our standard form. So we now have y minus 2 equals 3/2 x minus 9/2. 3 over 2 times -3 is -9 over 2. So next, we're going to move the x term so that it's over to the y side, and then our next step is going to be getting rid of that 2 that's there as well. So when we subtract the -3/2 or subtract the 3/2 x, that leaves us with that bottom green equation. We've got -3/2 x plus y minus 2 equals -9 over 2. So let's just move that -2 over to the other side as well. And that leaves us with this bottom equation. Now we're ready to clear the fractions. We see that we have 2 in the denominator, both of them. So I'm going to take that entire equation and multiply not just by 2, but I want that a term to be positive. So I'm going to multiply every term by -2. And remember, we've got to distribute to every term in the equation. So when we do that, we end up with positive 3x, used as most to get you through the computations. Negative 2 times y is minus 2y. Negative 2 times negative 9 halves is positive 9. And negative 2 times positive 2 is minus 4. So lastly, we just have to combine the 9 and the minus 4. And our standard form looks like so.